Okay, so this talk is about InSpec and Skynet testing that. The title said something about containers and something about Solaris. So who's here for the Solaris part? Yes. Anybody else? Like, Sean, all right. So that's what we're going to look at. My name is Dominik. I'm from Chef. I do something there between engineering and talking about products. Find me on any of those addresses. I'm here to talk about InSpec. A friend of mine and myself, we started the idea of InSpec sometime by the end of last year. InSpec is basically a birth child out of the server spec movement. So you had the question already, but since some people came in, who's familiar with server spec already? Okay, that's huge. So I'm going to try to keep the intro short, since you're all familiar with that. InSpec stands for Infrastructure Specification. It's a made-up word, but essentially it's infrastructure testing. That's what we do. If you know server spec, it is very, very familiar to that. It actually is started on top of the server spec project as a security and compliance solution. That's where it originated. It turns out that we went back and changed a couple of things in server spec and had to fork the whole thing. So it became its own and separate project. This is going to be a 60% intro talk and 40% a little bit of an advanced topic. So we're going to look at what we changed for one part when it comes to creating your own resources. The testing is very, very familiar to you already. So you describe something on your machine, you run the test, it gives you an output, hopefully 0 failures. If you have failures, you might not be able to go home yet. Why do we do infrastructure testing? That should be familiar to all of you, but just to recap, because things break. And there's something called normal accident theory. Have you ever heard of that? Anyone? Okay, I'm lucky because I can talk my ass off about that now. So normal accident theory stipulates that whatever system you have, as long as it gets more complex, more people get involved, more time passes, any of those, it will break sooner or later. Normal accident theory is founded on things like 3 Mile Island, Chernobyl, or the Apollo mission. So that happens to software too, but it's not going to be as much of a catastrophe unless somebody is working in a nuclear power plant here. Who's doing code testing in nuclear power plants? Anyone? Okay, so we're good. Don't have to restructure this. Okay, so why infrastructure testing? And there's a lot of reasons that come up. If you follow TDD movements, there's a lot about code style, architecture style, and so on. But the one thing that has been proven so far is this, to reduce the number of defects. So that's the #1 reason you do that. The second reason, and this is how we got started with InSpec originally, was that we wanted something for security and compliance testing. And server spec gave us the right framework, and we extended it with the language we needed for the security guys, with context and so on. And there's actually a separate talk which was yesterday, but the slides are already up online if you want to look at them, by Michael Getz, who talked about how to turn compliance policies into code. So it's about codifying compliance. And the structures you see in there will give you the idea of why we created the things we did around server spec. What is special about InSpec? So 2 things, and 2 which we're going to focus on. #1 is test any target, test anything you want to hit, which you also got from the title, right? Solaris to Docker. #2 is to be expressive. And I think this is kind of a diversion we're taking from the classic server spec model. So the second part is going to be a bit more advanced. So test any target. What do you run these days? Is anybody still automating on top of bare metal here? Okay, no 1%. 2, a couple more.
Eventually we all are.
Eventually, yes. The reason I'm saying this is because I got the others coming up. So VMs and containers. I know some people at IBM are actually really into automating on top of metal, which is interesting. Of metal, the physical machine. The guys I've been talking to, they are getting into containers as well, but they were doing the same thing we do with containers without containers, which was interesting to me. What do you use? Linux, I think most of you, right? Anybody here for Windows? Windows side of things? Okay, awesome. And then we have got other and legacy, which is where Solaris, ARX, BSDs. It's the same person. I'm hitting all of you with those. I'm going to reference the Microsoft part here. There's another talk, which was also yesterday, by Stuart Preston, who talked about infrastructure testing with Microsoft Azure. Microsoft is actually very important to InSpec as well, but so is every other platform. We just want to be really open about supporting them. Oops. So I'll give you a tiny how-to. Installing InSpec, that's simple. Or you just git clone the whole thing and use the repository you have. It does say chef, but InSpec, like ServerSpec, is agnostic to your automation. I don't care if you use Chef, Puppet, Ansible, CF Engine, Bash, Salt, or anything else. It works with all of them because it has different problem domain, which is trying to hit. If you first, if you download InSpec, you run a command line, you get this nice help menu, which tells you what you can do with it. I'm going to jump into the most important one, which is I want to run a test. So I describe a test in a small Ruby file, for instance. I execute that, which basically means I run that test on my machine. If I get 0 failures, I'm done. I'm happy. You can run singular files, but you can also run something called profiles. Profiles are like independent test structures, which we started for compliance, but you can use them for anything else you want to. Like the compliance part is syntax sugar on top, which you can use, but you're not forced to. Profiles, in that sense, profiles are also test profiles, which you can use independent of compliance if you're into that. And of course, you can do things like that. If you're, like me, too lazy to type 2 lines, you can just run it from a remote URL like GitHub. We are testing local nodes like this, but I already talked about testing any target I want to hit. So one of the things we do is, if I want to talk to a remote machine, for instance, which I can reach via SSH, like a Linux node, that's how I do it. I keep putting my mouse here. That's how I do it. You don't require anything on that remote host. You don't require Ruby, you don't require any agent, it's just pure SSH in the shell. That's it. The second thing is with Windows, same thing. You can just WinRAM to your host, to your destination, and run those natively. As long as your tests are actually written for Windows, you'll be fine. That works. And then finally, why many are here today as well, is containers. And again, no Ruby on the container, no agent on the container, no SSH on the container. You can just take your Alpine image and test it like that. And that's going to work. So let's go into the testing part, and I'm going to try to show off something as well. This is the anatomy of a test, very simple. You all know ServerSpec, so I want a certain package, wget, to be installed. And I want to have a script file which is owned by root and should be a file and should exist in the target. This is how any type of test may look. It doesn't matter if it's containers or not. Containers is just a special case. This is how I'd execute that. Once I've written that, I point it to my Docker target. That thing runs. Those are, for instance, 4 examples. It comes back with failures or not, and you're done. And the reason it works like this is because of how the whole thing is structured. So the tests are the things you write on the top layer. The resources are the abstractions we use below that, and I'm going to show you how to create own resources and extend the language. Then we have got something called train, which is our transport. Stands for transport interface. It allows us to talk to any type of target, whether it's remote or local, over a unified interface. It's very, very much reusable, and we're currently working on getting that back into Test Kitchen. So it originally evolved out of Test Kitchen, and we are trying to put it back in. And then finally, you've got the operating systems and the targets you're actually talking to. Test Kitchen is actually a very interesting scenario. So we have something called the Kitchen InSpec plugin. And Kitchen InSpec basically replaces ServerSpec and Buzzer in Test Kitchen with a very small InSpec runtime. And the reason I'm bringing it up is because I want to actually show you the Solaris part. So this is a small Solaris test I've put up. It just checks whether packages and services on Solaris are installed and whether I'm actually running on Solaris. So if I switch to my terminal, like here, and I have the test in the test folder. This is really hard with a microphone. You can see it here. It's basically the same thing. If I were to run this natively, it would basically give me errors, but I'm running this with Test Kitchen now. So if I do a kitchen list, you'll see that I've got Solaris running here. If you think I'm talking my ass off because I just changed the name, then we can just do that or that. That's a real Solaris box. So you are familiar with Test Kitchen, you know how long the verify stage usually takes because they go on the box, they install a lot of things, and then they run it. The kitchen verify with InSpec looks like this. That's it. It's the same thing, just zero installation. So I only did the converge before that, which installed Solaris and put some stuff on it. This is just the verify stage. Not too long. We're trying to make it shorter. Right. So that's how the Solaris test looks like. Again, InSpec allows you to do a couple of things since it's target agnostic. If I do the same thing with my containers for a sec. So I've got containers running on my machine. And I've got a small test running here. Really, really small one. That's always there if you know Linux. So if I run this locally, that will just give me the results, and that's fine for the local execution. But if I want to run this against one of my Docker containers, for instance, I've got an Ubuntu somewhere down there, I just point it to the target and the container ID, and I'm not going to type all of it because it's going to take too long. And so that's going to come up okay, right? Is that good actually? Well, I could still be talking my ass off because the test just passed on my local machine. So one of the ways to find out whether you're actually targeting the right thing, InSpec has a detect command, which I can point to my target as well. That's going to tell me that, yep, this is an Ubuntu box actually, because my local machine is, because my local machine is actually an Arch Linux. Here we go. And there's another thing which is great in InSpec, which is helpful for debugging. So if I point this to the container, I can actually open up a shell, an interactive debugging shelf. So if you've ever written tests, you're usually waiting very long for those tests to hit something. You might, the whole cycle might take you a couple of minutes. This is the faster way if you just want to talk to a target and find out what's going on with that. So I can basically do so am I on Linux? Yes, it's true, but what am I running on? On an Ubuntu. How else could I find this out? No. I could basically run the command on the machine and give the std out, which is this. That works. I can check for services, packages, whatever you want to. It's against the running live node. And this basically gives you an API to talk to any type of system you want to interactively. At the same time, the special case is, of course, testing things. Whoops. Here we go. So, all right. Let's get to the interesting part, to be expressive. So, one of the goals we had was actually that if you look at tests like this one, and this is very similar to what I got during my audits, security audits, where people were running similar tests to this, and they were just trying to check whether certain settings and certain files were okay. They weren't doing them in server spec, they weren't doing them in, they were actually running them in bash. But the principle is the same. They were just, running bash commands and setting for regular expressions. That's what you usually get. Are you familiar with SCOP profiles, security profiles here? Always the same. A lot of those actually match for file existence and file regular expressions as well. If you look deep into them, that's like, I think I did a scan with the CentOS profile right now because we're going to support those natively in InSpec as well. And what it's doing is 80% of that is basically matching against simple resources, which was interesting. But this happened, and what they were doing was not checking whether the protocol was true, but what my auditors were doing was whether I'm doing some badass TCP tunneling, which I was. And I actually tricked them because they did the regular expression, and as every auditor or security person will tell you, I'm going to hack you through your regular expression. Well, I'm going to hack my auditor through their own regular expression, which was, of course, not a good thing to do, but that's what happens if you let security people write regular expressions. So we established something that's a bit more expressive and leads to less errors, which looks like this. Because we actually understand certain resources, like configuration files. So this one, for instance, says, describe my SSHD configuration, and its protocol version should compare to 2. You could also say it should equal to string representation of 2. We added the compare operator because people were getting, like, again, auditors, right? They were getting confused because the setting in the config file was a number. To them, it was a number. And they didn't understand why they had to put it in strings. So this is a clever operator to take care of those. So yeah, this one leads to less errors. And so the question is, what resources are there? Well, there's a few, which we created already. Documentation on those, so all of these are open source, they're part of the InSpec project. Documentation is up on docs.chef.io. And one of the things we are working for the 1.0 release is actually to unify that under its own website. But that's a separate issue. But let's be honest, I mean, custom resources are something really, really interesting because what you're trying to do might not be in our InSpec code yet. For instance, we don't have resources for PHP configs. Oh yeah, that's a bit contrived. But maybe for Docker resources, for instance, which we haven't added yet, which are planned, but they aren't just in there. How would you create that on your own? And this is the answer to the question. You basically, I talked about the profiles before, those testing profiles. Testing profiles for us are a way to structure our tests, and they are a way to structure resource packs as well. So here I have got a mixture out of a test profile, which has some controls, and out of a section in there, which is here. And the library actually defines my own resource, which I'll call Gordon here. The InSpec YAML is required for every profile, basically the metadata stuff. And it helps us to identify that we're actually working with a profile. And this is how you create a resource. This is the smallest resource you can come up with. You just create a Ruby class. You inherit from the InSpec resource. Yes. Version number 1. That's the current version we have for the interface. And then you give it a name. As soon as you have that, you can use it in your tests. Now, okay, the resource exists, but it doesn't do anything, right? That's a bit stupid. Let's do something more useful. So this resource is going to give me content, which is just going to say, signal me. And if I actually match that in my test right now, I can use it like this. I can see whether the content equals what I expected. Okay, that's still a bit too little. We actually want to talk to operating systems. So this is how the whole talking to operating systems bit works. In this example, you see something that you might find a bit new. It's this InSpec keyword. And the InSpec keyword is available to all of the resources that we create. It's automatically in there. It's the one feature which we add to all resources, and everything else is Ruby code you can do on your own. But that's the one thing that is always going to be available to you. With that InSpec keyword, you can actually talk to other resources in the pack. So for instance, in this example, I'm talking to the file resource, which exists within InSpec. And I want to open up this file that is there, and I want to look at the content of that. So that's how you do that. And you can do the comparison again. If you open a real configuration file on the system, that's how it would give you back the result. And the way in which it works is basically this. And this is a real example out of the InSpec code. Because all of the resources which we have in there have been constructed the very same way. For instance, the SSHD config actually inherits everything from the SSH config, because they are in principle very similar. The SSH config then uses InSpec file to talk to the operating system. And that file resource basically talks to train, which I mentioned before. It's this transport interface, which is the unified way of talking to whatever operating system you're at. And that provides the file in the end. So here's a bit of a better example. So this time, I'm going to read out the YAML file I have on my system. And in order to do that, I use the YAML resource. So I showed this before. We've got YAML in our resource packs, which is already defined for you. This is how you would construct the very same resource. And you would just point it to the YAML configuration on the operating system and read out its parameters. And they'll become available to you. And then you can simply test them. So describe the parameter hello to equal world, if we set up the example like that. And that's going to give you the result. If you think about it, if you're familiar with ohive from Chef, or factor from Puppet, or anything else, that's basically extending the whole model to any type of node, whether I'm installed on it or not. And that's what we're going to do. Okay, the way forward. I'm just going to wrap this up. So the way forward for us is we are going to hit the 1.0 release. I'm communicating March here. Hopefully going to be end of February. With that come a couple of things. So number one is dependency resolution. We don't resolve them automatically, but we have recently added support for pointing to supermarket, and you've already seen the GitHub support in there. So imagine that concept extending where the InSpec YAML is like a Berks file or very similar concept, which you point to something you're interested in and it's going to pull in the dependencies. It works with resource packs just the same way. Resource packs, obviously, we get that as an added bonus of the dependency resolution, but we're also going to separate them code-wise. And then we've got attributes. It has a lot to do with configuring your tests. For instance, if you're testing things like a Postgres database, you might need credentials for those if you really want to run those SQL queries. In order to do that, we're going to have a very clear interface on how to configure those values and make them reusable. And finally, there's going to be plugins, and one of them I already mentioned with SCUP, which is coming up very soon. So that's going to hit us too. And that's basically it. Okay, woo! And thank you so much.